Hey everybody, in this video we're gonna talk about layout analysis or layout exploration in our PV farm application, or specifically how the BIM information modeling nature of our software helps to understand layout, its features and metrics. First of all, let's talk about BIM. I would say that the BIM has three major components. First of all, the equipment itself. So we have a proper representation or detailed 3D model of arrays. So basically you can see the truck itself, the piles, the motors, the caps, the strings and the wiring, right? So that's the first part of the BIM. So the second one is the fact that those objects are filled with the right information. So energy, equipment, wiring, commercial information, cost information. It's about dimensions, module information, specific position and string information. So basically the objects in a 3D model are fulfilled with the information, and as the user goes and create layout and then calculate LV wiring, MV wiring, trenches and stuff like that, so the objects are being populated more and more with information. So in a way it's about accumulating information, useful information as you go through the process of designing layout. That's the second component. And then the third component, the fact that those objects are connected together. For example, if I'll check this block number 1, basically you can see here in the Model Explorer that we have a proper hierarchy. On this example, so we can see that we have a bunch of trackers connected to one combiner box. So we can see the whole circuit. So I can select the whole circuit, you will see all the objects. Then we can see that in a bunch of combiner boxes connected to central inverter. So I can basically select the whole circuit, or I can go and see the central inverter itself. And then everything goes to the transformer, which is here, and then the circuit of the transformer. And then everything goes all the way to my substation, which is here at the top level. And then if I select everything connected to this substation, you will see pretty much the whole layout. As you see, we have a specific data structure. And why is it useful? And the reason why it is useful is that when you do any changes in any circuit, in any combiner box circuit or inverter circuit or block, those changes and those information, the data, it flows from the modules and strings up to substation. So you can immediately see all the changes on how many objects connected to the substation, what's the energy, what's capacity, what's the amperage, what's the current, and all this stuff. So basically three major components: 3D modeling, then the right information, the useful information, valuable information, and the third one is relations or connections in between objects. So that's about BIM concept, and now we're gonna talk about what we can do with this layout and how can we understand its features and metrics. The easiest way to start is to basically open layout metrics, where we have all the relevant information about layout itself, including cost, total cost per DC watt or construction cost breakdown. Then we have a specific section about equipment, which shows how many objects, how many equipment objects we used. For example, in this particular layout, we used two types of trackers, so the 72 mods and 90 mods. If you want to understand specifically where those trackers are, we have a select by property value panel, which helps to choose a object, specific object, then its property, and then the value. For example, if I want to see where my shorter trackers are located, I can select all of them, so I can visually see where they are if I have any problems with that. Okay, so then let's go further. So we have a specific section about layout import, what kind of parameters we used when generating that layout, and then general basic metrics like GCR, module total area divided by footprint, how many different row heights we have, and then the power information, AC, DC, average low voltage, medium voltage. We don't have medium voltage calculated, that's why it's 0. So and then obviously the quantities. So another way of analyzing the layout is through our so-called property charts. again, as I said before, the BIM nature of our objects, of our layouts, allows us to do a fancy analysis by simply going through object properties, right? So for example, if we have a bunch of blocks here, right? So we have block 1, 2, 3, 4, 5, 6, 7, etc., right? So they are all grouped around transformers, so which means transformer accumulates the data about the objects inside, right? So in that specific way, I can actually go pick my transformers here and then pick my DC-IC ratio or ILR ratio, and I can colorize my hierarchies. So I can see the blocks with the highest DC to IC ratio and the blocks with the lowest DC-IC ratio. The same works for the cost. I mean, as I said, again, data is being accumulated. If I select my transformer in here and I'll go down to the cost information, so we will find this parameter which is called group cost, which basically includes all the cost of the children connected to this transformer. So in other words, this is the cost of the block. So I can go here, I can choose my group cost as a parameter, which will basically allow us to analyze the cost of the blocks. So if I'll just colorize those hierarchies, we will see the most expensive blocks, and so we can go through all of them. Here is 11 the most expensive blocks with the price from 2.8 millions to 2.9 millions. This cost doesn't contain all the information because we didn't generate it MV via and we didn't put some labor factors, but it still shows us the cost of the blocks taking into account the equipment itself, low voltage wiring, trenches. So we can go and analyze what we can do about that. And the same logic applicable for voltage drop or any losses. So let's say if we select a specific combiner box circuit, and then we go to this combiner has the information about low voltage wiring, average voltage drop, losses, total losses, which means total losses in the circuit. Okay, so in the same way, we can go here, we can pick a combiner box instead of transformer, and then we can find the circuit LV average voltage drop. And so we will see that most of our combiner box circuits, if we will go this way just to see the whole layout. So we can see that most of our combiner box circuits, they have average voltage drop from 1.5 to 1.66 percentages, but we have some I would say not healthy combiner box circuits, so we can go through them, we can colorize those hierarchies, and we can analyze this type of stuff. So another way of layout analysis can be done through the Model Explorer. So let's say if we will go and generate medium voltage wiring with default parameters, so we will see that the hierarchy here has changed in the Model Explorer, right? So instead of substation and then blocks, we can see substation and then medium voltage circuits. So in that particular case, I can actually select any of the circuits. And so you can see that it's selected in the 3D model. So we can find the ones with the highest voltage drop or with the smallest voltage drop, and we can kind of isolate them and understand what's going on. For example, in this particular one, we have this trench road, which is happening simply because we minimize the trench length, and we needed to run like one trench to collect the wiring from a couple of different blocks located in different places. But in this type of analysis helps us to understand where we have the MV circuits we can improve, or like what do we need to do. Maybe we need to consider more trenches or less trenches. So we can kind of do this type of analysis with the Model Explorer itself. Okay, but let's say you need to do a more in-depth analysis and you need to build a custom schedule and export it to Excel and to do your type of calculations or assumptions, or maybe for the cost estimation purposes. Okay, so in that particular case, we have a specific panel called quantities, and this panel basically contains all the information about all the objects and all the parameters in the model. So it contains like hundreds of thousands of rows, and as you scroll, those rows will occur more and more and more, and you will have more and more information. Okay, so this is why you need to use filters, and you need to group objects in a proper way to build a proper schedules, right? But before we go into custom schedule, I will show you a couple of templates, because you can build templates here. For example, we want to see the information for MV wiring, right? I just apply template, I go to wire, I can see the circuit index, and then inside the circuit index I can see the wire size, and then the material, and then the length. So the same if I will apply LV wiring, so I'll see LV and then DC, and then DC feeder, 350 kc mil or any other cable. And so this is type of the templates we can use in here. So you can see the length, you can see the cost which came through the catalog, and so you can see the total cost, for example, in this particular one. The same applicable for racking system. So we have an X tracker, we have two types of trackers, and then we have a grouped by the wind load position, and then the ID, and then the cost of each tracker. So, but let's talk a little bit about how to build a custom schedule if we need for some in-depth analysis. So I'm going to reset my view here, and I'll go in filters and then type, and then I basically will select only tracker piles. Let's say I want to build a schedule or specification for tracker piles, and then I will go to my columns and will choose which parameters I want to see here. So let's say I want to see ID. If I'll pick type, we will see tracker piles, so less relevant for us. Then we might search for some useful information. Let's say I want to see the pile size. Okay, so we see cross sections. Then I want to see pile position, and then I want to see pile weight, maybe pile length. Okay, so in this particular case, we see the same length because we didn't place an equipment on the terrain, but for the sake of this exercise, it's fine. So then let's say I want to group those objects. I want to group them by pile size. And then I want to group, so we can see the pile size, and then we go and see many objects with the same pile size. Okay, if we want to calculate the number of those objects, we just go to ID, value aggregation, and we do count, right? Maybe inside inside this group I want to group by pile position. In this particular case, I'll just move my next grouping criterion here. So we will see the pile size and then the pile position, for example, heavy array peer and standard motor peer. And then I can do a pivot mode, and I can expand all my information basically in here. And then I can go and build a chart. If I go to pivot chart, column, and for example grouped, so this is the visual way of representing and understanding of the schedule, right? So we can change the view how the chart looks like. In this particular way, we can do more in-depth analysis. We can kind of build a proper specification structure, visualize it in a way of charts, and then we can find some insights and use those insights when making decisions about our layout. Okay, so let me just summarize. So I showed you that BIM nature of our software helps us to do some fancy search, like specific search by specific parameters, or to build some property charts and to see the most expensive blocks, or the circuits with the highest voltage drop, or any other circuits. Then the Model Explorer can help you to visually understand the, let's say, medium voltage circuits or blocks information, and to see the places where we need to refine something, or to do some extra work, or to change something. And then layout metrics. This is the most high-level window where you can see the major metrics about layout, and then our quantities panel is the place where you can do more in-depth analysis. So those are tool helps to do a layout exploration or layout analysis, and we're gonna do more videos like that. So if you have any questions or requests, send them in any channel you have, whether it's YouTube, comments, or LinkedIn, or send them directly to me, so we will address them in our next videos. Thank you very much for your attention. Have a lovely day. Bye bye.